Okay, so your test is Tuesday. The test is only going to cover P2, P3, and P4. Now, there's still one more part of P4, which is the factor completely. So the only type of factor completely question you're going to have is like what we did when we did the difference of two squares, where you're going to have to factor out a GCF first and then factor the difference of two squares. So you'll get a question like that. So you won't have to factor out a GCF and then factor the trinomial like we did yesterday. Now you'll be given trinomials, both the easy ones with a 1 in front of the x squared, and then also the more difficult ones where there is your a value is not equal to 1. So you'll get those. So P2, P3, P4A, B, and C. You can focus on those homework assignments as well as the notes. Now, keep in mind, in this Algebra 2 honors class, our reviews don't necessarily reflect exactly what the test is going to look like. So it is your job to make sure that you go back, you review your homeworks, you review your notes. If you're looking for additional practice, you can use your textbook because we already set up the WebAssign link. You can always go there and you can read the textbook. You can get exercises from there. They have the odd answers in it. But I think the homework we've given you has lots of practice. So again, the best way to be successful on the test in this class are going to be to do a lot of practice because you need speed. So 16 questions. I'm not sure exactly how long we're going to give you for it, but 16 questions for the test on Tuesday. So what I can do here is I can work through this. I did post the evens. I'm going to go ahead and post the odds as well, but again, you can use Calc Chat to check. So I can go through and just review some of these beginning ones because I know it's been a while since we saw the exponents, but I can go through here and work some of them out for you. So for 31, it says to using properties of exponents to simplify. So remember, when you multiply exponents that have the same base, you add them. But the key thing to remember here, and I saw a lot of this on the quiz, when you raise a power to a power, you need to multiply. So I'm going to go ahead and take care of the power to the power here first. And I'm going to multiply the 3 times 3 for the x. But then also remember, this power of 3 is also on the 4. So we're going to go ahead and I'm just going to leave the 3x squared there first. Then I'm going to apply that power to the power. 4 to the third power is 64. And then x to the third raised to the third power becomes x to the 9th. Now I can multiply my coefficients here. 64 times 3 is 192. And then remember, when you multiply variables that have exponents, you add them. So this becomes x to the 11th. The next one, I need to simplify the numeric part, so the coefficients. So that's going to simplify to 1/2. And then the y's, I can subtract them. So 5 minus 1, and I get y to the 5th. So this is going to simplify to y to the 5th over 2. If you put the 1 in front, that would be acceptable because I reduced 5 over 10 to the 1/2, and then I subtracted. Remember, this y has an assumed 1 on it, so I'm really doing y to the 6 minus 1 power, which gives me y to the 5th. It's positive, so it gets written in the numerator. The next one, remember to apply the power to the 3 and to the a. So this becomes 9a squared. And then I'm going to multiply. 9 times 6 is 54. And then I add the exponents, a to the 5th, and I'm done. And then this one, this was just working with your negative exponents. So here, whenever you have a negative exponent in a fraction, to make it positive, you just move it to the opposite spot. So the a squared was positive, it stays there, and just move the b to the -2 up to the top. And then, let's see, for this one, again, you're going to just add your like bases. So here I could add my a's together. So I could combine the a's together. And then I'm going to combine the b's together. And then I could assume that this has a 1 coefficient here. So 1 times 3 is just 3. And then if I add the a's, assume a 1 there, a to the 3rd. And then for the b's, I'm going to add 4 plus -2, and that's going to give me b squared. Over here, you can either choose to move the negative exponents or just subtract them from where they are. So notice here you've got a 6 squared, which becomes 36. Then what I could do for the u's, if you don't want to move them, you could just subtract. So like for the u's, I could do 3 minus -2, which will give me u to the 5th. And then for the v's, I could do -3 and assume a 1. Minus 1 gives me v to the -4. So this tells me I'm going to write it in the denominator. So I can go ahead now and put all of this together. So now in the numerator I have a 36. The denominator I still have the 12. The u goes to the top. The v is in the bottom. And then I just have to simplify the 36 over 12, which gives me 3 u to the 5th, v to the 4th. The other way to handle this, same problem. Let me try to do it another way for you. U -2v. If you'd rather move the negatives to the bottom, if it's in the top, and this one, since it's in the bottom, move it to the top, you can do it that way as well. So you can also move exponents. So if you finish this by just moving things around, this will become 36. The u to the 3rd was already positive, it stays. The u to the -2 will move up. And then the 12 stays there. The v to the -3 will move down. That v was already there. And then now just go ahead and simplify the 36 over 12. And then go ahead and add the u's. And then add the v's. And you get the same answer that I got when I just subtracted the exponents. Again, on these negative exponents, you have different options. But just be careful with the signs. So again, the solution file is also posted in the assignment, as well as you can watch this video as well. Backwards. All right, remember whenever you have a fraction that's under a radical, if it's easier for you to see, you could split it and give each one its own little radical.
Again, Jessica Bowlby, please report to Student Services. Jessica Bowlby, please report to Student Services. Thank you.
The cube root of 64 is 4. The cube root of 125 is 5. So this would just simplify to 4/5. Same thing on part B. This is a square root. So square root the 81, square root the 100, becomes 9/10. Here again, whenever you see this, something like this, when you see the index and the power is the same, they cancel each other out. So this answer is just 216. Same thing here. The index and the power cancel, so it's 32. You could go through and do it individually, but just realize that whenever the exponent and this are the same, it's going to cancel it. Because if you think about it, if we were to turn this back into fraction exponents, it would be 32 to the 4 over 4 power. And 32 to the 4 over 4 power is just 32 to the first, which takes you back there. Okay, so for 51, notice it says to rationalize the denominator. So here, what I need to do is get rid of that square root in the bottom. Now, when your denominator does not have a plus sign or a minus sign in between those numbers, all you need to multiply the top and the bottom by is the radical. So then now, the top, the numerator doesn't have a radical, so I just put it side by side. The bottom, remember we're making a pair of 3's here, so when you make a pair, it comes out, so the 4 is already out, and then when you made the pair, that 3 comes out. Now, if you're recognizing that you need to simplify this, you could either multiply it and get 3 radical 3 over 12 and then have to go back and simplify. But even before I simplify or multiply, I could realize I got a 3 here and a 3 here. I could get rid of it and then, or reduce this. This becomes a 1, this becomes a 4. Final answer, radical 3 over 4. Then number 53, now we've got a subtraction sign and an addition sign on 53 and 54. So here's where I need to multiply by the conjugate. I can't just get away with multiplying by radical 3. I have to multiply it by the same expression, but opposite sign. So I'm multiplying the numerator and the denominator by 2 plus radical 3. So it's opposite sign of what's in the bottom. So then now I have to FOIL essentially. The bottom, the top, anything times 1 is itself. So then the numerator is just going to stay the same. Now, if you blank out and you forget that when you multiply something by its conjugate, this times this, really all you have to do is first and last. And let me just demonstrate again to show you how when I FOIL that, outer and inner are going to cancel. So when I do first, 2 times 2 is 4. When I do the outside, 2 times radical 3 gives me 2 radical 3. The inside is going to give me negative 2 radical 3. And then the last is going to give me pair of 3's, so negative radical 3 times positive radical 3, the 3 just comes out. Notice this inside and outside canceled. So now I'm just left with doing 4 minus 3, and my denominator is going to equal 1. Now it's not always a 1, you're just doing first and last. So again, anything divided by 1 is itself. So just 2 plus radical 3. For 54, we're going to do the same thing. Now, if this numerator on any of these had like a binomial, then you'd be FOILing the top as well. These are just coincidentally where it's just a 1 in the top. So I'm going to go ahead and rationalize by multiplying by the conjugate. So radical 5 minus 1. So 1 times anything in that numerator is just the same thing again. Notice these are opposite signs. That's the conjugate. So again, when you multiply by a conjugate, just do first and last. So when I do first, I get radical 5 times radical 5, which pair of 5's, the radical goes away. And then 1 times negative 1 is negative 1. So the numerator stays square root of 5 minus 1, but the denominator becomes 5 minus 1, which is 4. And you're done. And just to go over the rational expressions. So for the problems that have a fraction exponent, remember the denominator is the root and the top of the fraction is the exponent. So what I'm doing here is the square root of 16 and raising it to the third power. Square root of 16 is 4. 4 cubed, 64. Now, sometimes you may not be able to do the root first. Sometimes you'll have to do the exponent first and then find the root. But if at all possible to do the root first, makes it a little bit simpler because it makes your number smaller. On the next one, remember that negative exponent does not make the number negative. It turns it into a fraction, or think reciprocal. So I'm going to put it underneath. The denominator is the root, and the numerator is the exponent. Soon as I moved it to the bottom of the fraction, that negative sign went away. Cube root of 64 is 4. Then I'll square it. 1 over 16. I think I've done a lot of it. All right, so this page is done. 72, not so much a common mistake, but I just want to show you again, remember what happens when you multiply something by its conjugate. So here, when you see two binomials, even though they have radicals, we're still going to FOIL this. So we would do the first. And again, when you do first, you do outside numbers with outside and inside with inside. So 3 times 3 is 9. But if you recognize you're multiplying a pair of 5s, so instead of doing 25 and then square rooting it, just take the 5 out. Now, this is actually its conjugate, but just to show you, when I do outside, this gives me, and I know this gets kind of messy because you got a radical and a variable. This becomes 6, radical 5, and then the x. And then the inside gives you the same thing, but it's positive, radical 5 and x. And technically the order here doesn't really matter. If you wanted to put the 6, the x, and then the radical, that works as well. And then finally last, 2x times negative 2x gives me negative 4x squared. Now what'll happen here is these are going to cancel. And then here I have to multiply 9 times 5 and then drop down the negative 4x squared. These are not like terms. I can't do anything with them. Now, the one thing that I wanted to show you again, please, 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 let me go back here. Let me find a cube. Do not do this on Tuesday. Do not just distribute the 2 to the 2x and to the 3. Write this down 2 times and FOIL it. I guarantee you some people are just going to do this and say the answer is 4x squared minus 9. You will get the whole thing wrong. So what you need to do, remember, when it's a binomial squared, I can't stress this enough, write it down 2 times and FOIL it or memorize the pattern. But it's a lot easier to write it twice and FOIL it, and you get this times this is 4x squared. This times this is negative 6x. Same thing in the middle. And then last is plus 9. 4x squared minus 12x plus 9. Notice if you would have just put the exponent of 2 on the 2x and the 3, you missed when you're doing this. Common mistakes are students are gonna miss out on that middle term and you're gonna lose everything on that question. So remember, write it twice and FOIL it. Also on the subtraction of the polynomials, Remember, do like a keep, flip, change. It's going to save your signs if you're not subtracting anything. So remember that. So like 176 here. It says to subtract this from this. So what we're going to do is when we set this up, I'm going to be writing this one on top. 20x squared minus x plus 3 minus, and now this one underneath it, now because we're subtracting, here's where you really need to do the keep, flip, change, because everybody's going to remember to subtract this one, but remember we're subtracting them all. So what I recommend you do is change this to an addition and change all of these signs to opposite now. And then you're not going to mess up anything on your signs. So then here, positive 6x to the fourth minus 9x to the fourth gives you negative 3x to the fourth. Then this gives you negative 9x squared, nothing to group with the x. And then 3 plus negative 16 is negative 13. Be very careful on the subtraction questions. Patterns. Does that start there? Starting at 81? Or before that? Is that good there?
Yeah, especially the trinomials and more than 2 numbers.
Okay. All right. So you want more like focus like 87 down?
Yeah.
Okay. All right, you're good with the cubes though?
Yeah.
Okay. Now, see how it says here, factor completely? So just to show you on 81, you will get a question like this where you have to pull out a GCF first. The GCF here is x, and then what remains after you divide both of these by x, then you're left with x squared minus 1, which is the difference of 2 squares, and you can keep going. So if on these where after you pull out the GCF, if you fail to keep going, you're going to lose, most of the points. So just remember to keep going on the factor completely, and it'll be a difference of 2 squares. Again, none of the trinomials after you factor out the GCF will need to be factored further. All right, so let me jump down here to number 87, because she wanted to see one of those. So again, I'm going to look, there is no GCF. So here's where I'm going to do the 4-term polynomial instead of, and do factor by grouping instead of guessing and testing. So I'm going to multiply the first and the last, and this is going to give me 20x squared. So I'm looking for 2 numbers that will multiply to give me 20 or 20x squared, and the same 2 numbers that when I add them are going to give me the middle, the 21x. Now, don't forget about the obvious. A lot of students forget about the 1 times the number. So this one is actually 1x times 20x, which will give me 1 times 20 is 20, but when I add it, I get the 21 that I need. So now I'm going to turn it into the 4-term polynomial. I'm going to keep this one and this one the same. What I'm replacing is this middle one with the 2 factors I just found. So this becomes 20x squared, and then I'm going to replace, and it doesn't matter the order that you put them in here. So I'm going to go ahead and put it in as the 1x and the 20x, and then I'll put the plus 10. Now I need to make 2 groups. So I can make a red group here, and let me make a blue group. So the GCF of my red group here is going to be x. So I'm going to divide, and then I'm left with 2x plus 1. My greatest common factor of my blue group is going to be 10. Gonna divide. Remember, after you divide, these two need to look the same. If they don't, you've picked the wrong GCF. So now I rewrite that once, the 2x plus 1, and then I take the two GCFs that I just divided by, put them together. And again, on this one, it doesn't matter if you put it as x plus 10 or 2x plus 1. The order here of the binomials doesn't matter, but it matters where that 1 and that 10 ended up. Number 88, same thing. I'm going to go ahead and I'm going to, let me just rewrite it here so I have lots of room. So there's no GCF, and again, you won't have to look for a GCF on the trinomials. So I'm going to multiply beginning and end. I'm looking for factors of 24x squared that when I combine them or add them, I get 14x. And those two factors of 24, if I do an organized list, it'll be 1 times 1x times 24x, or 2x times 12x, because now when I multiply these, I get the 24x squared, but when I add those two, I get the 14x I needed. So this is my combination of factors. And again, I'm going to rewrite this and this, but I'm replacing this with these guys. So 3x squared, replace the 14 now. And again, the order you put them in doesn't matter. So I'll just put them in like that. And now I'm going to make two groups. If you want, if you put the 12 first, it works the same way. And then I'll make a group here, blue. My GCF of the red group is just going to be a single x. There's nothing else in common. After I divide, I get 3x plus 2. After I divide the GCF here, which is 4, I'm left again with the exact same thing, 3x plus 2. Again, these need to look the same, which they are. So go ahead and write that down. And then put these in the second binomial. And you're done. 89 is already set up as 4 terms. So I'm just going to make groups here and then pull out a GCF. So for 89, I can make a red group and I can make a blue group. My GCF of red is going to be x squared. So here I'm going to get x squared and then divide it and I get x minus 1. GCF of the blue group is going to be 2. So then I'm left with 2, divide, and again I still get the same thing. Put these two together, x squared plus 2, and then the x minus 1. Again, or flip-flop it. Remember, there is no such thing as the sum of two perfect squares, and also 2 is not a perfect square. So you're done. Number 90, it's already set up as the 4 terms. So again, we're going to group. Soon as I see 4 terms, I'm going to look first to see if there's a GCF, and there's not. Then I make my 2 groups. GCF of the red group is going to be x squared. Divide it, and I'm left with x minus 4. GCF of my blue group is going to be 2. So then I'm left with 2 and then x minus 4. These look the same, so write it once. And then take the 2 GCFs, x squared plus 2. So for example number, now this one right here, I know it looks a little strange, but all we're doing here is pulling a GCF out. So notice this is what's in common to both. So you're dividing both of them by the GCF. So you would write that GCF outside. And then what's left after you divide here is x, and after you divide here is the 4. So be able to recognize something like that. Now 83, this is the difference of two perfect squares. So here, if you can recognize that 25x squared is perfect square, so is 49, all you need to do is square root this, and set up your two binomials. And then one will get a plus sign, one gets a minus. So the square root of 25x squared is 5x. Write that right here. And then the square root of 49 is 7. Always look for GCF first though. Like for example, 84, that one has a GCF of 9. So I'm going to divide it by 9 first. And then I'm left with 9, and then after the division, 4x minus 9. I still have a perfect square, difference of two perfect squares, so I got to keep going. So this will actually now factor into 2x plus 3 and 2x minus 3. 85 is the perfect cube. So remember, you're going to cube root. This will be in the first parentheses. The cube root of x to the third is x. Cube root of 64 is 4. I'm using my SOAP pattern. Same sign. The next parentheses is the x squared. Opposite sign, so O in the word SOAP. And then I'm going to multiply the x and the 4. Then the next sign is always positive. And then it's just the 4 squared. That trinomial that you get when you factor that cube cannot be factored any further. It will always stay just like that. Remember, when you have a number in front of your first term, the cube root of x to the third is 2x. The cube root of 27 is 3. So then I'm going to put the plus sign, same sign. Now in the next parentheses, I'm squaring blue. So this becomes 4x squared. The middle term is multiplying the 2x and the 3 with opposite sign, spell and SOAP. So this becomes 6x. And then the last term is the red one squared. And you're done.